This question has to do with set theory, and it goes as follows. There are buses in a garage. 10 of the buses are blue. So that's a distinction based on color. 6 of the buses are German models, so distinction based on where the buses were manufactured. And then there are 14 double-decker buses. So the first question asks us to sketch a Venn diagram showing all the defined sets. So we have 3 sets here. The set of blue buses, of which there are 6, the set of German models, and the double-decker buses. So I'm going to draw a sketch. Each set is going to be represented by a circle within this, sketch of a rectangle, which represents the sample space of the buses. So it's going to be the blue buses. It's for the German models. And D for the intersections. So blue buses, German manufactured buses, and double-decker buses. Now we know that there are 10 members or 10 buses that are blue, 6 of the buses are made in Germany, and 14 of the buses are double-decker buses. So this is a rough sketch of what you'll be required to do rough sketch of the solution to question 1. Obviously you need to do something neater in your exam. So here's obviously a neater diagram. So I'll just re-annotate. So this first circle represents the set of blue buses. This green circle represents the German manufactured buses, while the red one represents the 14 double-decker buses. So that's question 1 done. Now what about question 2? Question 2 asks for the use of set notation to represent the number of blue German manufactured double-decker buses parked in a garage. So we want to represent the number of buses that are both blue and German. Buses that are blue and German, buses that fall into this region. So using set notation to determine, to express the number of something, use the symbol n. So what's the number of members of a certain set? And we're saying blue German, meaning the buses are both blue and German. So they belong to the set of blue buses and the set of German buses. But of course, we're told number of blue German manufactured double-decker. So the buses must also be double-decker buses, meaning that I need to rewrite this as the number of blue. I should make a distinction between, so the number, this is an N, of blue and German manufactured and double-decker buses, meaning buses that fall into, how many buses are in the intersection of the 3 sets in this region here. So the number of elements belonging to this set here. Question 3 asks us to determine the numerical value of the result of question 2. If the number of blue and German buses that are not double-decker is 2, and the number of both blue and German buses is 11. So what does this mean? Well, let's take it step by step. Now, let's use the information we've been given. we're told the following. We're told this. Is 2. I'm also told that the number of elements in B union G is 11. So I'm just going to show that on the diagram. I'll use a different color. Let's use purple. So if the number of elements in B union G is 11, we know that the number of, okay, that can really be shown easily. But B intersection G is this whole region. But B intersection G intersection D prime is just this region. So we're told that the number of elements in this region is 2. So what are we interested in finding? We're actually interested in finding B intersect G intersect D, which is the number of elements in this set, which is number of elements in this middle region here, which I'll just shade. So to simplify the process, I'm going to say let the number of elements in this region here be x, which means that, so we have B union G is 11. Now everything, if there are 10 elements, 10 blue boxes, it means that everything outside this region is 10 minus 2 minus x. That is this whole region here. If there are 6 green boxes, it means everything in this whole region is 6 minus 2 minus x. So what is B union G? B union G is this region, which I'm going to shade. So this region I'm shading is the region that's given by 10 minus 2 minus x, which is 8 minus x, which means it has 8 minus x elements. So this region here has 8 minus x elements. This region has 8 minus x elements. I'm going to do that for you here. It has 8 minus x elements. Now this region has, so 6 minus 2 is 4, so 4 minus x. This region has, the region I'm shading has 4 minus x elements. So B union G is the region, this, pink region, plus this region in the middle here, plus this gray region. So if we're told that the number, I'll show you this. Now, the number of elements in B union G is, from the diagram, 8 minus x plus 2 plus x plus this 4 minus x term. 4 minus x, and we were told that this left hand side term is actually 11. So we know that 11 is equal to 8 minus x plus 2 plus x plus 4 minus x, which means that 11 is equal to, so I'm just going to group numbers and we're going to group like terms together. So I have 8 plus 2 plus 4 minus x plus x minus x. So what I have here is 11 is equal to 14 minus x plus x has 0 minus x. So 14 minus x is 11. I know that if I subtract 14 from both sides, I have minus x is equal to 11 minus 14, which is minus 3. So x is 3. So now I know that x is 3. So because x is 3, the intersection of B, G, and D has 3 elements. So now to part 4. Part 4 asks for us to determine the total number of blue double-decker buses. So we need to determine the number of elements in this set, blue and B and D. We need to find that. Now it says, but we're told that the number of elements in B to G prime is 3. So we're told that so the buses that are blue, the number of blue double-decker buses that are not German manufactured is 3. So how do we represent that here? Blue double-decker buses that are not manufactured in Germany is 3. So that is everything in this region here. So you can ignore the other. Well, what we can do here actually is have a new diagram. So from the old one, BGD, ten 614, so given that we determined that x is in fact 3, we know that this 8 minus 3 is 5, this 4 minus 3 is 1. So those are things we know about. We won't use them yet, just yet. We know that there are 2 members in that region and 3 here. We know that. So what we've been told here is that B intersect D intersect G prime. So everything in this region here, B intersect D intersect G prime. So as you know, B intersect D is this whole region here. But because we're looking at the intersection of B intersect D and everything outside G, it's only going to be that region. So we're told that there are only 3 members here. I want to also find B intersect D. Well, B intersect D is the whole region. So that's this plus this. So the answer is, the number of elements is simply 3 plus 3, which is 6. So that was an easy question. Because in case anyone can't see this, there are 3 elements in this component, and then there are 3 elements here. So for the whole region, which is the whole region in green, there are 3 plus 3, which is 6 elements. Finally, we're asked to determine the total number of buses. How many buses are there in total? That's what this question is asking. And the answer is not 10 plus 6 plus 14. That's an easy mistake to make. It's an easy mistake to say, well, the total number of buses, the number of blue buses, and number of German manufactured buses, and number of double-decker buses combined together. Because some of the blue buses are also manufactured in Germany, and some of the buses manufactured in Germany are double-decker, some of the double-decker buses are blue. So we need to actually take our time to work this out. And it will be helpful. Well, let's note that we have that. It will be helpful to use a new diagram. So just keep this in mind. I'm just going to use a new diagram. I'm going to place that just here. So the first set was a set of blue buses. There were 10. There are 10 members. Second set is buses made in Germany, 6. The final set is the double-decker buses. There are 14. We determine that x is 3, so we have 3 there, we have 2 here. We also just determine that there are 3 members here. Now, given that there are 10 blue buses in total, given that this is 3 plus 3, which is 6, and this is 7, 8, so 3 plus 3 is 6, plus 2 is 8, we know that there must be 2 elements here. That is, 2 buses that are just blue, that are not made in Germany and are not double-decker. There are 2. So that's complete. For this case, so there's one missing piece of information. The question, this should say how many buses are there, and should be given that the number of element in D intersect G intersect B prime is equal to 1. So D intersect G is this whole region here. Intersect B prime is just this region here. So we're told that there's only one element there. And from that, you know that there are no elements in that region, because 2 plus 3 is 5, 5 plus 1 is 6. So we have the 6 German manufactured buses, so there's no bus in that region. There's no element in that region. And then because there are 14 double-decker buses and we have 3 plus 3 plus 1, which is 7, it means that there are 7 elements here. So the total number of buses is simply given by adding up all the numbers here. And that is 2 plus 2, which is 4, plus 3, which is 7, plus 3, which is 10, plus 7, which is 17, plus 1, which is 18. So there are 18 buses in total. That is B union G union D is equal to 18. Now, if you simply said the answer was 10 plus 6 plus 14, you would have gotten 16 plus 14, which is 30. They're not the same. So the reason why this result is wrong, this result that gives 30 is wrong, is as follows. Now, if you're using this approach, what you would be saying is that, okay, so I'm counting the number of buses, so I'm counting the number of blue buses, which is 10, but I'm counting the number of German manufactured buses, which is 6. But by counting that 6, what you've done is you've counted these buses again, because these buses are part of the blue buses. 2 plus 3 plus 3 plus 2 is 10. So you've counted them. So counted this. The first time when we counted the blue buses, we counted these numbers. Then when we're counting the German manufactured buses, we're counting this, and we're counting this again. So you're counting some buses twice. And already you can see how we're already wrong with that approach. So the approach I used here was to count the number of distinct buses and add them all together. That way you don't double count.